Alright, let's look at the Laplace transform. Alright, so Laplace transform of function f of t is defined as the improper integral. Alright, so Laplace transform of f of t is integral from 0 to infinity e to the negative st times f of t with respect to t. Alright, so once we evaluate this improper integral, this actually becomes a function of s. So sometimes we use this notation, capital F sub s. Right? Again, note that this is a function of s, not the function of t anymore. All right, so let's look at a couple of examples of computing Laplace transform. All right, so let's find the Laplace transform of 1, and s is assumed to be a positive number. All right, so here. So by definition, we have an integral from 0 to infinity, e to the negative st, right? And the f of t in this case is 1, so times 1, which really doesn't do anything with respect to t. All right, so times 1 really doesn't do anything. I'm going to just go ahead and erase that, so we have that. So antiderivative of e to the negative st would be e to the negative st over negative s, right? Then we're going from 0 to infinity. Actually, since it's an improper integral, I should probably use this limit as t approaches infinity, and this is going to be our t, right? Then, so this is going to be equal to limit as t approaches infinity, right? So I'm going to plug in t, so it's going to be, actually, I messed it up. All right, since t is already used, so I shouldn't use t. Let's use b, how about that? All right, sorry about that. So you have a b here. All right, here's a b. And this is going to be b. All right, just confusing using the same variable for two different things. All right, so if you plug in b, you're going to get this. It's going to be negative e to the negative sb over s minus, right, and we're going to plug in 0. So there's a negative sign, so I'm going to turn it into a plus. Right, e to the 0 is 1, so it's going to be just 1 over s. All right. All right, since s is positive, as b approaches infinity, e to the negative infinity is going to approach 0. So we know that this guy, the first term, so this first term approaches 0. All right. So therefore, what's left is just simply 1 over s. All right. So this is the 1 over s, is the Laplace transform of 1. Right. So let's look at another example. All right. So Laplace transform of exponential function e to the at. Right. Assuming that the s is greater than a. All right. So this is going to be equal to integral from 0 to infinity, right, e to the negative st times e to the at with respect to t. All right, so I'm going to combine that, and let's see, so you're going to have, maybe I'll combine that here. So if you combine these two exponential expressions, this is going to be e to the, and I'm going to pull out the t, and I'm going to pull out the negative sign. So it's going to be s minus a. All right. So if you find the antiderivative, so I'm going to again turn it into a limit as b approaches infinity. All right. Then you have antiderivative of e to the negative s minus tt would be e to the negative quantity s minus a t over negative s minus a. And you are going from 0 to b. Right, so this is going to be, we still have to take the limit as b approaches infinity. Right, plug in b, so you have a negative sign is there. So you have a e to the negative s minus a times b. Then you have a s minus a. Right, and a minus, but there's a negative sign, I'm going to turn it into plus. Right, e to the 0 is 1. Then you still have s minus a. All right, so we have that. And since s is greater than a, e to the b is going to go to infinity, so it's a negative infinity. So again, first term approaches 0 because e to the negative infinity. All right, so what's left is 1 over s minus a. All right, so this is just a couple of examples, and we're going to look at quite a few more examples later. But the Laplace transform is defined in terms of an improper integral defined here. Right? But remember that the resulting function is going to be a function of s, not t. All right, that's it. I hope that this was clear.